Hello, my name is Roger Parada, and I am in Dr. Dasgupta's Spring 2018 class. And today we will be going over simulating a titration in Excel, and we'll be doing the simplest one, which is a strong acid versus a strong base. Same concentration, and we'll be keeping the concentration equal, but as you can see, we'll be changing that equal concentration. And we have our three tables here, and I have a blank chart over here, as you can see. And I've already set it up so that we have our volume of base added versus the pH. And when we fill in our charts, this graph will fill in as well. So we have, as I said before, here's our volume of base added, starting with 0, increment by 10, and as we approach the equivalence point, we'll get closer and closer by very small increments until we get to 99.95, and then 100, which is our equivalence point, marked in red. And then we slowly increase away from our equivalence point until we hit about 110, and then we increment by 10 and then 20 here. Because about 140 is a good place to stop. You should have more than enough excess base to see the general shape of the curve. So first, after we set up our graphs here, our charts, we'll want to calculate the concentration of H+. And you see we have some reference cells here. And basically what we have is the millimoles of acid minus the millimoles of base, all divided by the total volume. So that's volume of acid times concentration of acid minus the volume of acid times the volume of base times the concentration of base, and in this case it's 0, and then all divided by the 100 milliliters of acid plus the milliliters of base. You can see we have dollar signs here on some of these, and so what that indicates is absolute reference. And the reason we have those is that we don't want this value to change. We don't want these values to change as we drag our equation down. We don't want them to be a D3 and then D4, for example. We want this to stay as D2. And so the only thing we want to change as we drag this equation down is the milliliters of NaOH. So we have our value here, and we drag it down until we get to 99.95, and then we have our pH, and our pH is simply the negative log of our H+ value. Then grab it by the corner right here, click, drag down. And we don't want to drag these H+ values all the way down, because past the equivalence point, Excel will give you negative values, and in this case that doesn't mean anything physically. It's nonsensical to say you have a negative concentration. So we'll calculate our value separately here. Square root of Kw, excuse me, and the pH value of 7 fills in automatically. So since we're going to get nonsensical concentrations of H+, now we'll calculate the OH concentration. Now we set up a very similar equation here. So it's millimoles of base minus millimoles of acid, which is constant, as you can see by the absolute reference for the volume and concentration of our acid, all over the volume of acid originally, which is 100, plus the changing volume of base. And again, the only cell that isn't absolute reference is the base, the volume of base. Excuse me. And once again, we click, drag, and that's our increasing concentration of base as we add excess base. And then here we have our POH, which is just, as you know, the negative log of OH concentration. There we go. And to complete our chart for our pH values, we just do 14 minus our POH values, get the little black cross, double click, and there we are. And because I've already set this axis, this to be the x-axis and this to be the y-axis, then we have this graph on our screen. So very quickly, I've already set this up to work likewise. So we just fill in our charts in much the same way we did above. We've simply modified the equations to fit these reference values here instead of the ones we previously used. Negative log OH equals 14 minus POH drag down here. And again, 7 is the pH at our equivalence point. And just quickly, once again, same thing here. So, per Dr. Descoupter's request, a little bit about myself. I am a gamer, old school Nintendo type. I love specifically The Legend of Zelda, and aside from being a chemistry major, I'm a philosophy minor, so I read a lot of philosophy, particularly philosophy of religion, and think about traditional religious questions from a philosophical perspective, and put them to scrutiny, I guess. It's pretty fun. And we are just about done. And there you are. So as you can see, as we dilute the concentration of both acid and base, our starting pH is higher. The pH we end up with gets lower as we dilute the concentration. And we can see that on our graph. Here's one I made earlier, and it looks very much the same. And just for kicks, here's a picture of me holding up a little book about philosophy. It's about the question about free will. I recommend it. Anyway, I hope this video has been helpful.